So the question is regarding the vertical force component and how it relates to friction. So I just made this question up. We've got a 5 kilogram object, 1,000 newtons applied to it at a 30-degree angle. The mu value is 0.2. Let's find the acceleration. And if I gave you time, you could figure out distance and all that stuff, right? Yeah, we've done an example of this, but it sounded like someone wanted another one. You're finding the acceleration. You're finding the acceleration. Okay. So when you see something like this, you should realize that you need to find horizontal and vertical. Okay? And FH is always F cos theta. 1,000 cos 30, and I'm going to need a calculator because I don't have any notes on it. I get 866. Is that what you get? That's newtons, right? That's horizontal component. You also need to find the vertical component. It's going to be F sine theta. Yeah, the applied force. So what that means is that there's 866 newtons doing what? Pulling it sideways, and 500 newtons lifting it up.
So they have to use this kind of stuff to lift it.
Oh, this is not going to work there.
Yeah, this is not a really good question. But when someone drops something from, say, like a building, is the acceleration always going to be negative 9.8?
Yeah.
Okay.
So what do you use to make
I got to make a change. This is what happens when I make stuff up on the fly, because I already can see. Does anyone see what's going to be the problem?
You can't plug it into your formula because you're missing both normal force and the friction.
Well, the normal force is based on the mass, right? But I can see here that I got 5 kilos times 9.8, which is 10. What's the normal force here going to be? 50, less than 50, but I'm already lifting up with 500. Okay, so I'm going to have to.
Yeah, you guys.
I got to make this a little heavier. Can I do that? I apologize. Again, it's what happens when you're making stuff up on the fly. I think
Someone to improve everything.
weight force is mass times gravity. 70 times 9.8. 600 and... Okay, so this means now, what's the normal force? We've got 686 down, but we've got 500 up. So how much does the normal force need to push to balance those off? The normal force is going to be 686 minus 500, right? The normal force only needs to come up with 186 newtons, because 186 newtons of normal force and 500 newtons of vertical component add up to 686, and then it's balanced. And once you've got that,
Have like words in it, so
huh?
you can say like find this, find that.
I said find the acceleration.
Oh, that's it.
So now I'm going to solve for FF. 0.2 is equal to FF over, normal force 186, right? Mhm. 37.2. So we got 37.2 newtons of friction. And what was our horizontal component? Some giant number like 866, wasn't it? I'm solving for acceleration.
Oh yeah, F9 equals M9 days.
What does that say, FL?
FH, horizontal component.
I could use that formula in a while, but M9 too.
So the net force here is the horizontal plus the friction. Lots of practice.
What is F8 plus F5?
Well, but it's in this case, there is no formula for F net. It doesn't exist. F net means add up all the forces that are present in that situation. No, there's just those two that are necessary, right? The FH is sideways, the FF is opposite that. And what you got your net force? What did I say, 70? Yeah. Yeah, that's a challenging question, there's no doubt about that,
I need words.
at this level.
Nobody knows what's the law.
So leave all hard questions like this one.
Or you could learn how to do them.
Well,
That would work
I
too.
learned that in one weekend.
Why not?
So now you text me and be like, yo, Mr. Bennett.
So this would be like 7 points then?
You can text me, but only if you don't talk like that.
Mr. Bennett,
Yo, Mr.
Good question, let's see, how many marks would that probably be worth?
or 8, because 3 body diagram.
1, yeah, 2,
Just not have any of those in the
3, 4, 5, 6, 7, right on, man.
Sick.
Mr. Bennett, you
Maybe one.
who doesn't know physics.
What?
I don't know.
You who doesn't know physics.